Okay, now let's start going over the second do now from week 3. So, as you know, my tip is always to read the questions first and then you go into the passage when you need to. So, it was assumed in the design of experiment 3 that cow lens proteins, and then we have these answer choices. This says 2 solutions containing lens proteins from cow lenses were prepared, one with glucose, one without. Only the glucose turned opaque. Analysis revealed that they had formed pigmented crosslink with the brownish color. So that's formed, so we know it's not have a brownish pigment. But then let's now go back into the passage. So experiment 1 says human tissue. Experiment 2 says human lens proteins. And here in the passage blurb, it says that dietary sugar may react with proteins in the body which damage and contribute to the aging process. But in experiment 3, we used cow lenses. So we went from human to cow. So the only answer choice that we can use here is react similarly to human lens proteins. So that means that this was done in order to replicate it without doing it in the human body, and that we can make them analogous. Alright, 29. Based on the results of experiment 1 only, it can be concluded that. So let's go to experiment 1. Now we read. A human tissue protein was dissolved in glucose and water, resulting in a clear yellow solution. After 30 minutes, the solution became opaque. Analysis revealed that an Amadori product, which you don't need to know. If it's in italicized, you don't need to know what it means. They'll usually define it for you. Had formed on the protein. It was determined that the Amadori products on one protein had combined with free amino groups on nearby proteins, forming brown pigmented crosslinks between the 2 proteins. The crosslinks are termed advanced glycolysis. I'm not even going to pretend to pronounce that. You don't even need to know. So, a word that we can't pronounce, age. Based on the results in experiment 1, it can be concluded that proteins can form disulfide crosslinks. Doesn't say anything about disulfides. Glucose dissolved in water forms AGE. We did have glucose in water, and then it formed AGE. Glucose can react with proteins to form crosslinks, and Amadori products are a result of glucose metabolism. So the answer here is C, because the glucose didn't turn it into the opaque solution first. It says that we added glucose in water, and then this product had formed on a protein, which means that the Amadori products combined with other proteins to form crosslinks. So that means glucose caused the reaction, so proteins formed crosslinks. So C is our answer here. Okay, number 30. As people age, the lenses in their eyes sometimes turn brown and cloudy, senile cataracts. Based on the information and the results of experiment 2, which of the following hypotheses is most likely to be valid? So, experiment 2. 46 samples aged 12 to 80 studied under a microscope. The lens proteins occurred much more often in aggregates formed by cross-link bonds than the lens, so crosslinks happen as you get older, and the crosslinks were disulfide and then indeterminate with brownish pigmentation. So, from experiment 2, we know that as you get older, there are going to be more disulfide and brown pigments. As people age, the amount of sulfur contained in the lens proteins increases. Senile cataracts are caused by cross-link bonds between lens proteins. Lens proteins turn brown with age, and older lens proteins are more fluorescent than younger. No. Fluorescence is how we looked at it, so it's not saying that that's the case. So the answer for 30 is actually G, because it tells us that as people age, the lenses turn brown and cloudy, so they get senile cataracts, and experiment 2 tells us that they have more cross-link bonds, those disulfide bonds. So it's the disulfide bonds that are causing the brown cataracts. 31. Which of the following hypotheses about brown pigmented crosslinks observed in experiment 2 is best supported by the results of 3 experiments? So, their brownish color is caused by disulfide bonds. They are natural formation, which can be found at birth. We already know that's not true because we are talking about senile cataracts here. They are caused by glucose in the diet reacting with the lens proteins, and they are formed when proteins are dissolved in water. So the answer here is C. because experiment 1 and experiment 3 discusses glucose, and if you read the passage blurb again, it talks about glucose reacting to form these bonds. So the hypothesis that dietary sugar causes the brown pigment and crosslinks found in older subjects is supported by the results of the 3 experiments, so we know that glucose in the diet, which is what they were studying in the first place. Alright, 32. Based on experimental results, lens proteins from a 32-year-old man, so that's not super old, 32 would most likely have more crosslinks than lens proteins from a 32-year-old woman. So we don't talk about the differences in our subject's gender or sex at all. More crosslinks than lens proteins from an 18-year-old cow. We can't say that because we don't know the relationship between cow age and human age here because they live different amounts. H, more crosslinks than lens proteins from an 18-year-old man, and fewer crosslinks than lens proteins from an 80-year-old man. So we're between H and J here. So more crosslinks than an 18-year-old and fewer crosslinks than an 80-year-old. But if we look here, it says the lens proteins in samples from older subjects occurred much more than did the lens proteins in the samples from younger subjects. And then here, that's talking about glucose, and this is talking about glucose. So, we're between H and J. H would seem to make sense because 18 is still younger than 32. However, the lens protein said all we know is that it occurs more often in older patients. Now, the difference between 18 and 32 is a lot less than the difference between 32 and 80. So we know much more often. It's going to be more experimentally correct to talk about the biggest age difference. So we're going to say fewer crosslinks than lens proteins from an 80-year-old man. And last question. People with uncontrolled diabetes, that's me, mine's controlled. People with uncontrolled diabetes have excess levels of blood glucose. Based on this information and the results of the experiments, a likely symptom of advanced diabetes would be. So, they have excess levels of blood glucose. And we know that glucose in the diet reacts with the lens proteins. So a likely symptom of advanced diabetes would be senile cataracts due to an increase of free amino groups, senile cataracts due to glucose interacting with disulfide crosslinks on lens proteins, senile cataracts due to age crosslinks of lens proteins, and kidney failure due to high levels of free. So, anytime that you see 3 answers that talk about the same subject and one that doesn't, your one that doesn't, you can immediately cross out. They will never give you 3 maybes and 1 yes. They will always give you 3 maybes and 1 no. So the answer for this question is C, senile cataracts due to age crosslinks of lens proteins. Because if you go to experiment 1, they have extra high glucose. So the glucose reacts to form these, which are crosslinks from the advanced glycosylation end products. So that answer comes from experiment 1.